so today is August 20th. And it's section P-2. All right, so like I said, it's linear models. So we're gonna probably go through this really quick because it's linear models. Okay, so we know linear means it's a straight line, okay, for our slopes. In the past, we pretty much just called them slopes. All right, we did use that, rise over run definition, and that's not ever going to go away. A slope is a slope, all right? But now, because we're going to apply the calculus, okay, to how it's actually used and what calculus is actually, how it explains the world around us, we're going to start having to think of a slope as a rate of change. Okay, because when I start describing something as a rate of change, all right, then I can start putting it in the context of something that I don't want to say in a real world application, but that's exactly what it is. It's going to represent something, you know, as one thing changes, something else is going to change. It's a rate of change, okay? This, we know the slope formula y2 minus y1 over x2 minus x1, right? That's when you've been given 2 points. Okay, we also know delta y over delta x. So there's your change, that delta y, change in the y's over the change in the x's. Okay, so you just kind of wrap your head around this. Slopes now are going to be a rate of change. All right, let's see, how much do I have to review? In general, if I have a, let's go slopes again here. If I have a line that looks like this, that has a what kind of slope? Positive. Okay, if I have a slope like this, it's a negative. All right, if I have a straight up and down one, undefined. Okay, and then when I have the horizontal one, that's the zero slope. Okay, so again, that's just kind of review. You got to be really, really good at that. Okay, now, could we apply this concept of slope to questions that you've not seen before? Okay, can you just think this through? All right, so as an example of that, all right, and just one, I don't know what kind of equations, I don't know what kind of questions you're going to necessarily encounter in the homework, but might be something similar to this, okay? What if it says, given, let's make that given the point on a line and its slope. Find 3 additional points on the line. Okay, so if we're given a point on the line and its slope, and that's the only thing you're given, you are not given the equation or anything. So if our point maybe say is 5, 2, and then our slope maybe say is a 1/2. Can you generate 3 more points? Given that information, because we know what the change in the y is right here, we know what the change in the x is right here. So if we know how y changes and we know how x changes, then we can do this. All right, how many possible answers are there? Yeah, there's infinitely many possible points. All right, so what is this? This is my change in my y's. This is my change in my x's. All right, so if I take the 5, 2, all right, and I change my x by 2 and I change my y by 1, I'm just adding because I could subtract, but I'm going to add. So 7, 3 is another point on the line. All right, do it again, add 2 more. So 9 and then add 1 more, so 9, 4. And then do it again, add 2 more. So 11 and then add 1 more, 5. So 11, 5. So that would be the, going up, those would be like the next 3. Okay, so that's just kind of applying. So, and I don't think you've ever had to do a question like that, but that's what you're going to encounter. You're going to encounter questions where you got to think a little bit and just apply the stuff that we already know. Okay. let's do another one of those just for practice. What if I gave you a point? Let's say I gave you the point -6, 2, but this time I told you the slope is undefined. Okay, so your point is -6, 2, but this time your slope is undefined. Okay, well, first of all, an undefined line is what, up and down? Okay, so what coordinate never changes? The -6 never changes, right? So then, if I'm trying to come up with it, well, I know I'm going to have -6, I know I'm going to have -6, I know I'm going to have -6, and then just pick random numbers. It really wouldn't make any difference. You could throw a 0 in, you could throw a 7 in, you could throw a -8 in. So because of what the line is, okay? So that one is, I am looking at that change in the X and change in the Y, but I'm just kind of thinking about, well, where would the lines be? Okay, so far, so good on that. A relatively easy, simple concept here. Okay. Let's take a look at various forms of lines. All right, again, you know these because we have done them over and over and over, but we're going to re-mention all of them just to be safe. Okay, so point slope form. And I'm starting with that one for a reason. All right, matter of fact, let's like put a little star by that one. Okay, the reason I'm starting with that one is because that's the one that we're going to use tons this year. Okay, that's the one that where you're going to do it. Like I know in like Algebra 1, Algebra 2, you were told many, many times, write it in, slope-intercept form. Okay, in calculus, this form is the best one to use because I got a y minus y sub 1. We know this, right? Mx minus x sub 1. Okay. You're going to later find out when we start getting in chapter 1, chapter 2 and stuff, you're going to find out that this slope thing is an extremely important concept in calculus. All right. It's a rate of change. And we're going to real easily be able to find that by using calculus. And we're going to know a point. So if I know a point and I know the slope, then point slope form, and then stop. Write it in point slope form. Don't rewrite it in slope, or I'm sorry, leave it in point slope form. Don't try to rewrite it in standard form. Don't try to rewrite it in slope and slope intercept form or anything, because if you have the answer right here, like say on the AP test, you've calculated that slope correctly by using calculus. You've got the point, and you write it correctly at this form. And then you manipulate it and change it into slope-intercept form and make a silly math error, then you're going to lose the point on the AP test. Okay, so we're not going to, once we get an answer, we're going to leave it. Like if you saw the other day, I was leaving things as improper fractions. Okay, stop on the AP test before you make a mistake. All equivalent answers are counted right. Okay, so it doesn't have to be in a certain form. They don't care. They're going to say, write the equation of the tangent line. They're not going to tell you what form it has to be in, but I'm saying we're going to use this because we'll have those two pieces of information. We'll get it right, and then we'll stop before we screw up. Okay. Now, that doesn't mean you shouldn't know slope-intercept form. All right. Tonight's homework even may ask you to use those other forms. All right. It's just strictly as a review. What this one is the y equals mx plus b. All right. Standard form. Which one's that one?
Y equals x plus b plus c.
Well, except x squared is a parabola, but it's got the a and the b and the c in it, right? Because I'm still linear. So standard form of a linear equation. This is the ax plus by equals c. So we've still got that ABC. Okay, and then when we did this last year, I gave you shortcuts, right? Remember the shortcut formulas? If it's in this form, what? We've got x-intercept. I don't need two little equal signs there. X-intercept is what over what? Ooh, do we have memorized from last year? Ooh, not this, not that, that's the slope. Negative b over 2a is the slope. X-intercept, your x and y-intercept. Why am I writing the wrong thing so much today? All right, y-intercept and x-intercept both start with c on top. And then, remember I told you last year the way to memorize it for x-intercept, coefficient in front of the x. So x-intercept is c over a. All right, coefficient in front of your y is the b, so then the y-intercept is c over b. And then the slope that Caitlin remembered was the negative a over b. And not that you can't calculate the x and y intercept, because we did that the other day, right? I mean, if you wanted to plug in 0, but what do? If I plug in 0 for y, what's that do? That takes that out, and then I solve c divided by a. Okay, so those formulas are coming from plugging in 0 for the appropriate thing. Same thing here. I would plug in 0 here, then I got a one-step equation where I take c divided by b. Okay, so it's not something new you have to memorize. Okay, it just kind of makes it a little bit easier. Now, this particular section in your textbook is going to do general form. So on tonight's homework, if it says put it in general form, we are going to use that. All right, we probably won't use it much after that. Okay, but general form basically just looks very, very close to this, but has everything on the left-hand side. Okay, now it is not take this and solve it to general form. It's just in general form, you've got your x term on the left, you've got your y term on the left, and you've got any constants on the left. Okay, do not add, don't look at this and go, oh, I need a minus there. Okay, because we don't. We're not taking this and solving this form. All right, we're going to move stuff around and everything, but when written in it as a formula, they're going to write general form like this. If there were a negative, what's the negatives in this formula do? And in essence, when we pull out that point, we take the opposite, right? So in a formula, if you see a negative, you pull out the opposite number. So we definitely don't want a negative here, because whatever that constant is needs to be that constant. Okay. So I did just be aware of that. I think that your assignment today is going to say, write it in standard form and general form. And all they're doing, it's a review section. So they're just trying to get you to practice all of the different equations. That's all they're trying to do. General form does have that equals 0 on there. Okay, so are we good on that? Because these are linear equations. Okay, all right, let's go parallel and perpendicular. Okay, parallel and perpendicular lines. Okay, so just to summarize, our parallel lines, what kind of slopes? Same slope? Same slopes? Okay, if they're parallel, they're same slopes. All right, are they also going to have, what can you tell me about the y-intercept? Yeah, they're going to be different, right? Because one will be on top of the other one, so different y-intercepts. In general, okay, if you got a positive slope, you got a negative slope. Okay, perpendicular lines. All right, so what's the deal with those slopes? Negative reciprocals of each other, so flip them around. One's going to be positive, one's going to be negative. So negative reciprocal slopes. Okay, so that's just in general reviewing that. All right, and obviously, if you're trying to do some type of problem with this, just stop and think about what you have and what you need. All right, and point slope form will be your friend, even when working on this stuff. All right, if they're saying write a line parallel to the given equation and goes through this point, well, if it's parallel, you know you're going to use the same slope and you got an extra point, so point slope form. All right, if you want, they want you to write the line perpendicular to the given line, and they give you a point on the line. Well, find that perpendicular slope. You got a point, so what form should you use? Point slope form. Okay. Now, unfortunately, I think your textbook tonight is going to, you're going to do point slope form because that's the easiest way to write the equation. And then I think your textbook is going to say, then rewrite into standard form, then rewrite into, all right, so we'll do it on tonight's homework. As we move forward, you're not going to, you're going to stop right there, okay? All right, so let's go ahead and do one like you're going to see in your assignment. Let's go find the general form of the equation of the line that passes through, I'm having problems spelling today, passes through 2, -1, and R, let's set this up into 2. Let's do a part A, that are parallel to 2x minus 3y equals 5. And then let's do a part B. So this way we can do one question with a part A, part B, and cover both examples here. They're perpendicular to at 2x minus 3y equals 5. No, no, you don't have your mask on. Oh, sorry. Yeah. All right. So this is what your textbook's going to do. They do want you to practice this general form. All right. So that's what? That's the AX plus BY plus C equals 0. So in other words, they want all the terms on the left-hand side when you're done. Something else that probably I need to re-mention about that standard form and that general form, that leading coefficient probably needs to be a positive integer. So if it's a negative, you're going to multiply through by a negative. If it's a fraction, you're going to multiply through by the reciprocal to get rid of the fraction. That leading term, there needs to be a positive integer, technically, for that to actually be in that form. Okay, so if I'm going parallel to this equation, then I've got to use the exact same slope, right? Parallel, same slope. So formula was negative a over b. All right, so negative a over b, which is going to be negative 2 over negative 3, which means I'm going to use a 2/3 for my slope. And I know the point, which is 2, -1. So I am going to do point slope form. Okay, and I'm about ready to run out of paper here. Move this up a little bit. Okay, so point slope form. When I do my y, is it going to be +1 or -1?
It's going to be +1 since it's a minus.
Yep, it's going to be a +1 there. I'm going to put in that 2/3 positive slope, and then I'm going to do x, and then because it's a positive 2 here, I'm going to do x -2 right there. Okay, now that's point slope form. All right, and after we get into this year later, you're going to stop right there. We're not going to switch it. But on today's assignment, they want you to practice that general form. So algebra manipulation. Distribute, okay? So y plus 1 equals a 2/3 x. All right, and then just go ahead and leave that 4/3. No reason to make that a mixed number unless you want to do the math a little bit there. Both of these terms have to come over to the left-hand side. I'm going to go ahead, when I move them to the left, I'm going to put them in the order that I need them in. So this term needs to be first. So negative 2/3 x. All right, I need the y term next. All right, and then I'm going to add 4/3 to both sides. So 4/3 plus 1 will be what, 7/3? Might as well just leave them as improper fraction. All right, now I can't stop technically for that general form yet because I've got a negative 2/3 right here. Okay, we don't want that. We want to keep that as a positive integer. So I'm going to multiply through by, what? How can I get rid of that fraction? How about -3? Because if I multiply -3 here, it'll turn it positive, and it's also going to get rid of my 3. Quentin?
Did you move it from that side to the side?
What, this?
Yeah.
Yes, I moved this to the left-hand side, which made it negative.
What if we
It still should come out right, because if I would have moved all these to the right, then the only thing I would have had to do is multiply through by 3. Okay, because when I multiply by a -3, watch what's going to happen. This term becomes positive, all right, and then I'm going to have a 2x, right? When I do this one, I'm going to get a -3y. When I get this one, fraction goes away, and I'm going to get a -7. Okay, so is that what you got? That's what you would have got if you would have kept going? Yeah. So it really doesn't make any difference. The reason I went to the left, well, I like going to the left for whatever reason, but this is all on the left. I just always write general fund equals 0 on the right. Okay. All right, now let's do this one. Let's think this one through. All right, so perpendicular to this line, well, I already know the slope of that line is 2/3. So if I'm trying to write a line that is perpendicular, then I'm going to use the negative reciprocal, which is -3/2, and I'm going to use the point that they gave me up there. So this time, I'm going to have -3/2, all right, and that point to -1. So I'm going to, because I have a slope and a point, I'm going to start with point slope form. Okay, so y, it's going to be set up just like the other one. +1 is equal to -3/2 x minus 2. All right, and then after we get past this section, you're good to stop right there because I have written a line that is perpendicular to this line and goes through that point. Okay, so that's my point. There's really no reason to switch that to some other form, except this section wants you to practice manipulating those equations. Okay, so I'm going to go ahead and distribute y plus 1 equals -3/2 x, and then negative times negative is going to be a positive. 2's will cross out, so a +3. Don't let me make a mistake. Again, I'm going to move everything to the left. So I'm going to move this guy to the left. He'll become positive. And I'm going to subtract 3 from both sides. So I will have a 3/2 x. And I'm going to go ahead and choose to put that in front so that it's in the right order for my general form. The y is just going to stay there. I'm going to subtract 3 from both sides. That'll give me a -2. All right. And then it's really close to general form. I have them in the right order. Everything's on the left-hand side, but this is a fraction. I can't have a fraction. So I'm going to multiply by, what am I going to multiply by this time? 2. Multiply through by 2. All right, distribute it through. All right, 2's will cross out. That's going to give me a 3x. Distribute there, 2y. 2 times that -2 is -4. And in all honesty, that's the step that people will forget. But like I said, we're going to do it on this homework assignment. I might put it on like the very first quiz we do. But then after that, I'm going to let you stop right here before you make a mistake. Okay. All right. So far, so good. All right. Let's go ahead. How many people want me to do the plug and check formula that you're going to have a homework question on? Or how many people think they can do that? If they say, here's a formula, and it's a new way to calculate the distance between a line and a point, do you think you could plug things in? It's plug and chug. It's a formula. Okay, in the past, I've always done that, okay? But I want to experiment with you guys. Let's see if you can handle it, okay? In the book, they're going to give you a formula you have never, ever seen. It's not one that I memorize. It's not one that anybody knows, but it is a legit formula. It works, all right? It's a special formula, just like all of our formulas, quadratic formula, all right, distance formula for 2 points. It's just another formula. But what that formula is for is if you know a point and you know the line, then you can find the distance they are apart with that formula. So it's just a new formula. All right. If you need to see an example worked out, you can download my notes from the website. It's on page 5. Okay. If you get stuck with that, I don't think you will get stuck. All right. Let's talk about tangent lines for a little bit. All right. We know what tangent lines are. We worked with them last year. Okay, so last year, the way we introduced you to tangent lines was what? We worked a lot with circles, okay? And then a tangent line, what? Touches in only one point along the outside line of that circle. So anywhere, okay? Right there would be my tangent line, so TL. Right there's my tangent line. Now, what can you tell me about the tangent line and the radius of that circle?
They are always perpendicular.
They're always perpendicular, regardless of how poorly I draw this picture. All right, that right there, all right, when it's along a circle like that, your tangent line and that radius is always going to form a 90-degree angle, okay? We did other lines last year, didn't we? Did we talk about this type of line? Maybe a little bit. Anybody remember what that line's called? No. Oh. Yeah, secant. That's a secant line. There you go. All right, so we got tangent line, we got secant line. Secant line goes through there twice. All right, and actually, when we start chapter 1, we're going to play with some secant lines, okay, and then we're going to ultimately come up with and approximate that tangent line, okay, because given this kind of stuff in pre-calc, and as long as we're sticking with pre-calc, I can find the equations of both of those lines. All right, but then you're going to find out as we introduce ideas, this limit idea, okay, then you're going to see that we're going to have to use another approach, okay? That's to come. So let's do just one little practice question, just make sure that we kind of remember this, okay? What if it says write the equation of the tangent line to the circle. Let's go with x minus 1, quantity squared, plus y minus 1, quantity squared equals 169. And then at the point 613. All right, and again, this question is phrased the way it is because of you've got to use your pre-calc knowledge to be able to do this. Okay, so all they're trying to do is warm you up a little bit to the things that we're going to be doing in calculus. All right, now we will see tons of questions in calculus where it says write the equation of the tangent line. All right, you are going to see that set of directions over and over and over and over. Okay, but right now when we do this, we're only using what we know in pre-calc. All right, later, you're going to be able to answer that question. You're going to be able to use calculus to answer the question. Okay, so we're building up to that as the year starts. Okay, all right, so what do we know? Do we need a little picture here? I'm not going to do a really good picture, but let's do a semi-sketch so that we know what we got going on here. All right, so this circle, what can you tell me about the circle? The circle is at, where's the center? Yeah, 1, 1. Okay. So like I said, I'm not going to draw this really accurate. Okay, my radius is 13. All right, and then if this point, obviously this point has to land on the circle, and it does because right there's your 13. So 6, 13. So I'm just going to do a rough estimate. Let's say this is out about 6. Right, yeah. But I'm just saying, yeah. So there's my point, rough estimate here. All right, an attempt to circle there. We're going to label this one 1. We're going to label this one 613. And if I actually, you're right, if I actually count it over, yeah, whatever. Okay. Now, I want tangent line right here. This is the equation. I want the equation of this line. Okay, we know that that radius is perpendicular right there. So to write the equation of this line, what do I need? I need the slope. I already got a point, but I need the slope. I need the slope of this line. Yeah, find the slope here, right? Because I've got 2 points. I can find this slope. Okay, don't let me screw this up. So what, 13 minus 1 over 6 minus 1? So 12 over 5. Okay. Now, what can you tell me about these two slopes? Negative reciprocal. So then that means I'm going to use negative 5/12. So now I've got my slope, and I've got the point on the tangent line that I want to use. Okay, and then point slope form, going to be the easiest. Y minus 13, negative 5/12, x minus 6. All right, now in these directions on this one, does it say rewrite it in general form or standard form or any other form? Nope. So stop before you screw up. Okay. But like I said, the reason they're doing this in this beginning P chapter is they want you to start thinking about this. All right, there are tangent lines everywhere. I can draw a lot of different tangent lines. I can draw tangent lines to specific circles. I can draw tangent lines to curves, which is what we're going to be doing. Okay, and then anytime if I can draw a tangent line, then I can write the equation of that line. All right, so like I said, that phrase right there, you are going to see me write tons this year. Okay, write the equation of the tangent line. And every time the type of question just changes based on what I give you. But that's our ultimate goal. And you're going to find out later that this tangent line is extremely important in calculus. Okay, that tangent line has a very specific meaning later on in upcoming chapters, and it's very, very important. Okay.